This meeting is being recorded.
Indra, a very good evening. Your preparation is going on well. Thank you for updating me the inclement weather and lack of electricity in your locality. May the situation come back to normal conditions soon. Moving forward in our today's learning, as you might have noticed, Archana generously share valuable material for national eligibility tests, namely CSIR, UGC, NET, and GATE. I'm trying to download them and save them. You can see by yourself. If there were to be electricity, you can join. Otherwise, I'll continue. These are the new materials Archana has sent. I take up one after other. Let me go to the file folder of Archana. So let's see, Indra. I'm slowly trying to download the material that Archana has kindly provided us. These are some of the standard textbooks from analytical chemistry, inorganic chemistry, and physical chemistry. Going forward, some more standard textbooks for reference are being downloaded. Let us see. You can see here, this is general chemistry, fundamentals of chemistry. These are the standard books we need to refer. Let us ensure if we have collected all the data from Google Drive. Quite often it so happens that we'll collect all the material and put it in folders and then we forget all about it. It should not be so. Now that we have the material kindly given by Archana and also some of the material you have collected, now we need to concentrate on studying each of these materials, especially we have noticed majority of the material Archana has sent contains previous question papers. That is very, very important. State level eligibility test, UGC, GATE. For all these competitive exams, a series of question papers were nicely collected because Archana has been in teaching for over 6 years. You can see here fundamentals of chemistry by Yoma in SI, yeah, Yoma in SI. It has 133 pages. And these are the contents of the book. Substances and reactions. Yes, atomic theory, chemical formula. Chemical equations, subatomic structure, the concept of mole, solutions and concentrations, electromagnetic radiation, and spectroscopy. Yes, the spectroscopy we can refer to this particular book. And also physical chemistry related to atomic structure, Alpha principle, Paul's exclusion principle, quantum numbers, electron configuration, Shapes of orbitals, chemical bonding, and solid structure. Trends in the periodic table, thermochemistry. Good. These are the various contents. Let us ensure that we downloaded all the material that Arjuna has kindly provided us. Yes, inorganic chemistry, basic chemistry, analytical chemistry, all these standard books were downloaded. Yes, here we have something like physical chemistry and organic chemistry also. Let us see if we have downloaded physical chemistry and organic chemistry. Yeah, physical chemistry, we do have on science, chemical thermodynamics, basic physical chemistry. Let us see what is the basic physical chemistry book that is recommended. Basic physical chemistry by Wolfgang Gartel. In this, mathematical basics, thermodynamics, kinetics, electrochemistry, yeah, quantum chemistry, spectroscopy. Probably these books are written in examination oriented way. That is why Archana has recommended these books. Chemical Thermodynamics by Leo Louis. In this, we have basically almost all thermodynamics books will be based on first law, second law, third law. You see, basic concepts, state function versus path function, intensive properties, extensive properties, theory of thermodynamics, first law, second law, fundamental equations of thermodynamics, calculus of thermodynamics open system, Legendre transforms and free energies, gas phase behavior, conditions for phase equilibrium, the Clapeyron equation. Yes, it should be so. Multi-component systems, the ideal solution model, partial molar properties, non-ideal solutions, stability, solid liquid equilibrium, gas solubility, and Henry's law. Henry's law. What is Henry's law in solutions? Concentration of a gas in a solution is proportional to applied pressure, isn't it? That is what is called Henry's law. Equation of state, thermodynamics from equations of state, chemical reaction equilibria. Yes, this is all about the physical chemistry books. Physical notes. What is this physical notes? Let us see. Frankly, to be honest, most of the books I have never referred. These are very different and new. I do not know why Archana has recommended these books. Maybe this is these books are written in the perspective of competitive exams like state level eligibility test and NET, NET, National Eligibility Test, and GATE. That's why Archana might have recommended we take a Mount and Neel. Let us see the syllabus in this particular book, physical chemistry. This is from Edinburgh, UK. Authors are from Edinburgh, UK. Uh, Syllabus or the content of the book is like this: states of matter, thermodynamics, the first law, enthalpy, thermochemistry, entropy, entropy and change, free energy. That's thermodynamics. Okay. Solutions, non-ideal, non-electrolyte solutions, solutions, colligative properties. What are colligative properties? The properties of solutions that depend on the amount of solute. What are colligative properties? What are the colligative properties? Depression in freezing point, elevation in boiling point, osmotic pressure, and relative lowering of vapor pressure. These are called colligative properties. Phase equilibria, phase diagram of phase diagrams of mixtures, ionic solutions, kinetics. In kinetics, what do we have? Ions in aqueous solution, thermodynamic. Yeah, let me see. Kinetics. Empirical approaches to kinetics, rate law, determination, energetics and mechanics, formation of formulation of rate laws in action, the kinetics of real systems, quantum nature of physical world, nuclear structure, applications of nuclear structure, quantization, quantization of energy and particle wave duality means dual nature of matter. The wave nature of matter, the structure of hydrogen atom, the electron atoms, chemical and structural effects of quantization. Yes, this is what was missing in the material that we received, the handwritten material. The statistical thermodynamics was missing in that. Here in this book, we have statistical thermodynamics as well. Let us go and see the various topics in statistical thermodynamics. Yeah, these things we already discussed. Molecular orbital energies. These are the molecular orbital diagrams of various. Yeah, this has to be carefully seen. Yesterday, there was some issue. I was thinking why the pi should come before sigma. Here you can see the correct order. Yes, this is the oxygen molecular orbital diagram. Yes, after two one sigma, one sigma star. Here it is two sigma. This is two sigma. Even in a published book, there can be errors. Two sigma star, three sigma. Here, one pi, two pi, four sigma. These orbital energy levels need to be carefully looked into once again because this is different from what we have discussed yesterday. We will look into it. Yeah, parity, Garade, Ungarade. This is what I said. Garade, Ungarade, parity. A center of symmetry is located at the midpoint of a bond in a homonuclear atomic molecule. What do we understand? For example, if we have hydrogen molecule H2, chlorine molecule Cl2, oxygen molecule O2, these are called homonuclear diatomic molecules, and the yes, from the center here to the center of second atom. This is what is called interatomic distance. Okay. What is told here is a center of symmetry is located in the midpoint of the bond. This is the center of symmetry. Any point on the molecule may be reflected through the center of symmetry to give a second point with identical physical properties. Molecular orbitals in homonuclear molecules can be described in terms of their symmetry with respect to this point, since although the electron density is identical by reflection through the center of symmetry, the sign of the wave function need not be. A molecular orbital whose sign is unchanged by reflection is termed as Garrett, abbreviated to G, whilst one whose sign is inverted is ungarrett, U. The sign of a bonding pi orbital is inverted through the center of symmetry and is denoted by U. The sign of a bonding sigma orbital is not inverted and is denoted as sigma G. So what is Garrett and what is ungarrett? It is very beautifully clarified here. What is X? X is the center of inversion. Term symbols. As with the distribution of electrons in atomic orbitals, we already know electronic configuration of atoms. Ah, oh, I did not share the screen. Very unfortunate. Yeah, only now I shared the screen. You can see here term symbols. The distribution of electrons in molecular orbitals may be denoted with the use of term symbol. The total spin angular momentum quantum number sigma describes the overall spin of the electrons in the molecule and is quoted as its multiplicity. A closed shell has sigma equal to 0 and a multiplicity of 1, a singlet. A single unpaired electron has sigma half and multiplicity 2. A doublet, two unpaired electrons have sigma 1 and multiplicity 3, a triplet. Heteronuclear diatomic molecules, yeah, linear combination of atomic orbitals. sigma to s star I sigma to p x pi to p y pi to p z pi star to p x pi star to p z, and this is 2p x sigma star. So this is the carbon monoxide molecule. Carbon has 6, oxygen has 8. 1, 2, 3, 4. In 1s already we have 4. 1s is not shown here. So 4 are here. 2, another 2 are in 2px and 2py. Here it should be shown as 2px, 2py, 2pz, 2px1, 2py1. Okay, so we have 6 electrons. Here we have 2 plus 2, 4. Here again 2px, 2py, 2pz. These things should be shown as degenerate orbitals, not like 3 different energy levels. So here we have already 4 electrons. The remaining 4 electrons are shown here 1, 2, 3, 4. So we have 2 here and 4 here. Total 6 electrons have to be accommodated in sigma star 2. And how many are remaining? 4. 1, 2, 3, 4. So there are no unpaired electrons. Yeah, first sigma comes and then pi. Pi to py, pi to pz, pi star to py, pi star to pz, sigma to px. This is the molecular orbital diagram of carbon monoxide. Yesterday we discussed a similar diagram for oxygen molecule. Strong solid phase interactions. Probably time is up. Let us stop at this stage and let us continue tomorrow. Bonding in solids, yeah, band theory. This is LCAO, means linear combination of atomic orbitals, formation of a band from a chain of hydrogen atoms, the resulting density of states. Beautiful. Yeah, this is what is called Fermi energy level when we deal with the density of states, electrons in bands. Fermi Dirac. Yeah, we are talking about 252. We wanted to actually go and see statistical thermodynamics, correct? So 252, where is 252? Ah, yeah, we are at the statistical thermodynamics. Statistical thermodynamics attempts to both qualitatively and quantitatively explain measurable properties obtained through classical thermodynamics, entropy, heat capacity, by analyzing the quantized behavior of systems at the molecular level. The Boltzmann distribution law, the partition function, separation of the molecular partition function, thermodynamic parameters, and the partition function heat capacity. Because the thermal component of energy of the system may be calculated from the partition function, the heat capacity may be calculated from the differential of this value with respect to time. The maximum molar heat capacity is equal to R. For each degree of freedom, that is, each independent mode of motion. Thus, a gaseous diatomic molecule may have three translational degrees of freedom, one per each orthogonal direction of motion, two rotational degrees of freedom from rotation about each of the two equatorial axes, one vibrational degree of freedom contributes R to the molar heat capacity, R by 2 from each of the potential and kinetic energy components. The first law, entropy and change, free energy, statistical thermodynamics. We'll stop at this stage and continue with the pending aspects of inorganic chemistry. Yes, molecular orbital theory of diatomic molecules, hydrogen and helium, homonuclear, second row diatomic molecules, parity term symbols, dipole moments, hydrogen and helium molecules, molecular orbital energy diagram, molecular bonding orbital. Okay. Hypothetical helium showing equal population of bonding and anti-bonding. Yeah, these are bonding, sigma star is anti-bonding interactions, four atomic orbitals. The molecular diagram for the second row diatomic oxygen is shown in figure 3 with the 8 UP electrons occupying the two degenerate bonding pi orbitals, the bonding sigma orbital, and two degenerate pi star orbitals to give a double bond overall. The 2p should be shown like this: 2px, 2py, 2pz. All should be in the same energy level, not like this. Where is degeneracy here? What is 1 pi? What is 1 pi? Why it should be 3 sigma? 3 sigma, why should it be coming in 2p? There is some error here, and this has to be carefully looked into. Let us refer other books, standard books for molecular orbital diagram of, yes, okay. This is correct. It should be so. Virendra, I will stop at this stage. So what did we see today is we do have very useful material, especially old question papers for UGC, CSIR, NET and SLET and GATE provided by Dr. Archana, and we have downloaded, and we have to carefully go through all the question papers related to inorganic chemistry and complete it by Friday. See you. Thank you.